So today we're going to be going over chain rule, but we're going to be using chain rule and applying it to other problems that we've already learned or seen before. Okay, so first one, very straightforward. Okay, it's asking to find the derivative of the square root of cosine cubed x. Okay, so following our 4 steps, the first thing I would do is actually rewrite. And this is what we talked about in one of my other videos, is that as soon as you see a trig function with a power, you should always rewrite it. Also, when we deal with roots, we often rewrite the root as its power form. So I have cosine x, I move the cubed outside, but then also that is all to the 1/2 power. So when we rewrite this, we see that we have a power to the power. So this is cosine cubed to the 1/2 power, and when you have a power to a power, you multiply those powers. So when I'm done rewriting, I simply have cosine of x to the 3/2 power. Okay? And now you can see that this is very easy chain rule, where I have a function inside of this function. Okay? So I split up my function. So my inside function is my u, which is cosine x, which leaves me with y equals u to the 3/2. We take the derivative of this with respect to u, and we get 3/2 u to the 1/2 power. Take the derivative of cosine, which is negative sine x. We multiply them to get our derivative. And again, we can't leave it in terms of u, so we change that back to cosine x. So we have 3/2 the square root of cosine x times negative sine x. And that's our derivative. Okay, so remember, rewriting and then putting it together. So when we simplify, we get negative, well, I guess I should rewrite the 3/2 first. So negative 3/2 sine x square root of cosine x, and that is the derivative. Okay, so rewrite, differentiate, simplify, just like what we've been doing. Now, the next problem. Find the equation of the tangent line to y equals the natural log of x squared minus 3 when x equals 2. Okay, so we're dealing with a tangent line problem. Okay, so remember, the tangent line equation is y minus y1 equals m times x minus x1. And I need x1, I need y1, and I need the slope to finish my equation. Well, they gave me x1. x1 is 2. So that's 2. I need y1. Well, y1 is going to be equal to the natural log of 2 squared minus 3. You plug in x and you get y. And 2 squared minus 3 is 1, so the natural log of 1, which is 0. So y1 is 0. Now we need slope. Well, what is slope? How do you find the slope of a curve? That is the derivative. So I need to find y prime. So I need to find y prime of this natural log function. And you can see that we have a function inside of a function, so we're using chain rule. So I come over here, u is my x squared minus 3. Y equals the natural log of u. The derivative of the natural log of u is 1 over u. The derivative of x squared minus 3 is 2x. We multiply these, and again, we plug u back in, so we plug this back in. So we get 2x over x squared minus 3. So that is my derivative, 2x over x squared minus 3. Now we want y prime when x is equal to 2. So we plug in 2. So this is 2 times 2 over 2 squared minus 3, which is 4 over 1, which is 4. So that's my slope, 4. Now, I have my x1, I have my y1, I have my m, so plug it in. Y minus 0 equals 4 times x minus 2. And that's the equation of my tangent line. So we're doing a problem that we've done before, but to find the slope, this time I had to do chain rule. Okay? Next. I knew it was going to do that. Find the instantaneous velocity at t equals 2, given the position equation that follows s of t equals 2t minus 5 squared minus 6t. Now, s does not mean speed, okay? S means position. In the world of physics, s of t is position dependent on time, velocity is v of t, and acceleration is a of t. The s actually stems from the Latin spatium, which means space, where an object is in space. So when you see s of t, that is telling you its position or distance. Okay? So that is our position equation. Now, from our notes earlier, we've found that velocity is the derivative of position. If we think about it, when we did average velocity in, say, physics, it was distance 2 minus distance 1 over t2 minus t1. Does that look familiar? From mathematics, we write it as y2 minus y1 over x2 minus x1, which is slope. So average velocity is nothing more than slope. But I don't want average velocity in this one. I want instantaneous velocity. And again, in our notes, I've talked about that before. Instantaneous velocity or instantaneous rate of change is the derivative, where average rate of change or average velocity is slope equation. So basically, this problem is asking us to find the velocity v of t, which is the derivative of position. So we need to take the derivative of this function to get velocity. And again, it will be a chain rule problem. The second part won't be. We know the derivative of 6t, which is 6, but here I have a function inside of a function. Now you can either FOIL this out and add up like terms and take the derivative of the polynomial, or we could just do chain rule, which is what we're going to do. So we're going to say u is my 2t minus 5, and y equals u squared. That's my chain rule setup. Then the derivative, this is 2u. This is going to be 2. So the derivative of that is 4u, or since we plug u back in of this, 4 times 2t minus 5. So over here, 4 times 2t minus 5, minus the derivative of 6t, which is 6. And since we're trying to find the velocity at time equals 2, we just plug in 2 for t. And this is my velocity equation right here. It's the derivative of position. So 4 minus 1, sorry, 4 minus negative 5 is negative 1. So this is negative 4 minus 6, which means my velocity is negative 10, which means we are going backwards. Okay. And then the last question, finding the slope of the tangent line. Again, when we first learned the slope of the tangent line, we were using the difference quotient. But at this point, we've already graduated from the difference quotient. We should not be using that again unless it specifically tells us to. If we need to know what slope is, if we need to know what the equation of the tangent line is, we're going to be using the derivative from now on. So basically, to find the slope of this, I need to find f prime of x. Okay? But you can see I have a function inside of a function, which means we're doing chain rule. Okay, so I'm going to come over here and I'm going to say, okay, my inside function is my 2x squared minus 2, which means y equals the square root of u. Now, we've done this problem many times. At this point, you should know that if you're taking the derivative of the square root of x, that's 1 over 2 square root of x. That is a derivative equation that you should know. Technically, you're supposed to change this to the 1/2 power, and then when you take the derivative, you get 1/2 x to the negative 1/2 power, right? This is the way you would normally do it, okay? And then the negative power would move it to the bottom, the 1/2 is the square root. But at some point, you have to start just memorizing or knowing these so that it makes your life easier. So for instance, the problem that we're doing here, when I go to take the derivative of this, the square root of u, the derivative is 1 over 2 square root of u. That's just something that I've memorized. And the derivative of 2x squared, which is 4x. Then you multiply, so you get 4x on top, 2 over the square root, and you plug this back in, 2x squared minus 2. This is my derivative. So I go back over here. F prime of x is 4x over 2 square root of 2x squared minus 2. Okay? Now I need to find f prime at 3 because that's where I want the slope at. So you plug in 3. 2 square root of 2 times 3 squared minus 2, which means you get 12 over 2 square root. And this is 9 times 2 is 18, minus 2 is 16. And then the square root of 16 is 4. 2 times 4 is 8. So you get 12 over 8, which reduces down to 3 over 2. So that is our answer. Now, looking at all these problems seem very different. But if we look at it as a whole, all of these problems together, notice a common theme. What does this problem ask us to do? Find the derivative, and we use chain rule. In this problem, we had to find the equation of the tangent line. But what calculus did we actually do? Well, we had to find the derivative of this to find the slope. And I needed to use chain rule. So this question also was derivatives using chain rule. The instantaneous velocity, to find that, we had to take the derivative. And to find the slope of the tangent line, we had to take the derivative. So basically, all 4 of these problems look absolutely and totally and unequivocally different. But in every single problem, all we're doing is using the derivative to find the information that we need. So one of the things that makes calculus difficult is this fact right here, that you need to know how they're going to ask you the problem.